Good morning. We're going to start with Chapter 4 Powers, Part 1. Objectives. Recognize the notation A exponent n and understand its meaning. Recognize that A exponent n designates the product of n factors equal to A. Recognize the particular cases A exponent 1 equals A and A exponent 0 equals 1. Calculate the product of two powers of the same number. Calculate the quotient of two powers of the same number. These are the materials you will use. Meaning of a power. Activity. Consider the following figures. Figure 1 where it is divided into 3 equal parts. Figure 2 where each part is divided into 3 equal parts. And figure 3 where also each part of figure 2 is divided into 3 equal parts. If you call P1, P2 and P3 the number of parts in figures 1, 2 and 3 respectively, then P1 equals to 3 denoted by 3 exponent 1, P2 equals 3 times 3 denoted by 3 exponent 2, and P3 equals 3 times 3 times 3 denoted by 3 exponent 3. Now write P4 and P5, taking into consideration how we wrote P1, P2 and P3. Then P4 equals to 3 multiplied by itself 4 times, and P5 equals to 3 multiplied by itself 5 times. Write P7 and P8 in the form of a power. Notice that P1 is written as 3 exponent 1, P2 is written as 3 exponent 2, and P3 is written as P3 exponent 3. Then P7 equals 3 exponent 7, and P8 equals 3 exponent 8. In general, A exponent n equals to A multiplied by itself n times, such that A is a decimal number and n is a natural number greater than or equal to 1. Now the definition, A exponent n is a power where A is the base and n is the exponent. Example, 7 exponent 5 is a power where 7 is the base and 5 is its exponent. Now to write or to find the value of 7 exponent 5, we write it in the form of product of 7 5 times. And to read 7 exponent 5, we can read it in one of the following ways. Power of 7 to the exponent 5, 7 exponent 5, and fifth power of 7. We have two special cases to read a power. One of them is of exponent 2, so we can use the word squared. Examples, 4 squared can be read 4 exponent 2 can be read 4 squared, and 7 exponent 2 can be read 7 squared. Also, to read a power of exponent 3, we can use the word cubed. Examples, 4 cubed can be read 4 exponent 3 can be read 4 cubed, and 7 exponent 3 can be read 7 cubed. Property 1. A exponent 1 equals A for any decimal number A. Examples, 3 exponent 1 equals 3 and 23 exponent 1 equals 23. Property 2. A exponent 0 equals 1 for every non-zero decimal number A. Examples, 3 exponent 0 equals 1 and 120 exponent 0 is equal to 1. Remark that 0 exponent 0 is not defined. It's not equal to 1. It is not defined. Solve as an application, exercise 7, page 50. Please pause the video to solve. Solution. 1.2 exponent 2, it is equal to 1.2 multiplied by 1.2 equals to 1.44. 1 exponent 5 equals to 1 multiplied by itself 5 times equals to 1. 4 exponent 4 equals to 4 multiplied by itself 4 times equal to 256. 3.4 exponent 0 equals to 1. Product of two powers with the same base. Activity. Write 2 exponent 2 times 2 exponent 3 in the form of product of numbers. Then write the product in the form of a power. Then conclude. Please pause the video to solve the activity. Now 2 exponent 2 times 2 exponent 3 equals 2 times 2 multiplied by itself 3 times, which is equal to 2 exponent 5. So we can conclude that we can directly add the exponents and the base stays the same. Rule: a exponent m times a exponent n equals a exponent m plus n, where a is any decimal, m and n are any non-zero positive integers. Solve as an application, exercise 12, page 51. Please pause the video to solve. Solution. Part A. 2.5 exponent 3 times 2.5 exponent 7 equals to 2.5 exponent 3 plus 7, which is equal to 10. Similarly, in part B, we have powers having the same base 3.2. We just add the exponents 7 plus 8 to get 15. And in part C, we have powers having the same base 4.9. We just add the exponents 7 plus 5 plus 7 plus 8 to get 20. Quotient of two powers with the same base. Also, we have to solve this activity. Write 4 exponent 5 over 4 exponent 3 in the form of product of numbers, then write the product that you get in the form of a power, then conclude. Please pause the video to solve this activity. Now 4 exponent 5 over 4 exponent 3 equal to 4 multiplied by itself 5 times over 4 multiplied by itself 3 times. Now we cross out 4 by 4 from the numerator and denominator. We're left with 4 times 4, which is equal to 4 squared. So we conclude that we can directly subtract the exponents 5 minus 3 to get 2, and the base stays the same. Rule: a exponent m over a exponent n equals to a exponent m minus n, where a is any non-zero decimal, m and n are any positive integers such that m greater than or equal to n. Solve as an application. Please pause the video to solve. Solution. 2.3 exponent 5 over 2.3 exponent 2 equals to 2.3 exponent 5 minus 2, which is equal to 3. We have in the base 11.2, we subtract the exponents 10 minus 7 to get 3. We have the base 5.4, we subtract the exponent 6 minus 5 to get 1. As an assignment, you have to review pages 44 and 45, part 6 from the textbook, and solve the homework exercises 8, 10, 11, page 50, and 13, 14, and 15, parts ABC, page 51, and 26, 27, and 28, page 52 from the textbook. Remark that you must study these powers inside the box and use it in exercise 13, page 51, and exercise 28, page 52. Summary. So a exponent n is a power where a is the base, n is the exponent. A exponent n equals to a multiplied by itself n times. To read a power, power of a to the exponent n, nth power of a, or a exponent n. Also, a exponent 3 can be read a cubed, and a exponent 2 can be read a squared. Properties: a exponent 1 equals to a exponent 0 is equal to 1, a exponent m over a exponent n equals to a exponent m minus n, and a exponent m times a exponent n equals to a exponent m plus n. Thanks for your attention.